Hello, ladies and gentlemen. A very good morning, and welcome back to the continuation video on the examples of linear functions. Today, like I mentioned in the previous video, we won't be having any practical life example, but the good news is that this is the last video of linear functions. We're going to be solving like three examples, which will be more than enough to give you guys an explanation of how to solve any kind of question. So let's begin, guys. So let us say if a question asks you to graph a linear function, as you can see here. Now, the good news in linear functions is that all you need is 2 points. You need 2 points, which are more than enough to graph the line. You can choose more, but if you have good skills of drawing straight lines with a scale, you don't need to choose more points. So the recommended is to all you need to do is find the x-intercept and the y-intercept. Now to find the y-intercept, guys, let's recall the form this equation is in. So remember the form. Now, if you guys remember this form, that is the form of the equation. So let us convert this to, let me convert it to the slope intercept form. So what do we do first? Let me move the 3y there. And then y. And then I need to split it, the common denominator. So that is your gradient, and that is the y-intercept, which is -2. Let us come to the plotting. So there you are, Mr. Scale. Let us plot the. So we know that our y-intercept is -2, right? And we need to find our x-intercept. So that's our y scale. And then, so just to make it beautiful, now once again, linear functions can be used in many kind of applications in practical life. Just to name a few, like you're working in a restaurant and you're selling pizzas. So to find the cost of a total number of pizza slices, and it goes on, the list goes on, you know. Okay, so that's our graph. Now we know that we already know that the y-intercept is -2. So let us make a dot at -2. Now how do we find the x-intercept? So x-intercept, all you need to do is to plug in y as 0. At the x-intercept, the y is 0. So 2/3 x minus 2, which gives us, so we have 2x is equal to 6. We have x is equal to 3. That is our x-intercept. So Let us plot the x-intercept. My apologies, the y-intercept is at the y-axis. So we have -2 at the y-axis. Then we have x-axis. This is what happens when you don't have your coffee in the morning. So let us now draw a beautiful straight line. If I wanted, I could take more points, but I think it's enough. So that's your line of y is equal to 2 over 3 x minus 2. I'll give you guys like few seconds to digest it so that I can erase it from my small little board and start with the next example. Alrighty. Okay, let's do one example for parallel and perpendicular lines. So let me take a random example. Let me take an example of a perpendicular line. Well, let's take a parallel line first. Let me find an example. So let's say write the equation of a line through three. So they have given you 1 point, and then they have given you and parallel to 2x plus 5y minus 3 is equal to 0, and parallel to 2x plus 5y. So guys, this is our question. Basically, they're talking about a line which passes through this point. They have given you 1 point, and they have said that this line, the one we're talking about, passing through this point, is parallel to this line. What do you guys recall when we say that we have 1 point given? Do you guys recall the point slope which is y minus y1 is equal to m times. So remember, we needed 1 point which is given in this case, and we need the slope. Now if you guys recall that parallel lines have the same slopes, right? So these are 2 things to remember. So let us find the slope. So we have 2x plus 5y minus 3. So let us find the equation first in the slope intercept form to make it easier. So we have 5y is equal to minus 2x plus 3. You guys, you notice the gradient is negative. It's going to be negative at the end. So we're going to expect that as the value of x increases, the y value will decrease with a constant rate. There you go. That is our gradient, guys. So what I did was that since this line is parallel to this line, we found the gradient of this line, which is -2/5. Now we have the gradient. We have the gradient of this line as well, right? So all we need to do is plug it in. So we have, let me write it with blue. So we have y minus y1 is equal to m times x minus x1. So we have y minus 2. Our y1 is -2, right? Is equal to, what is our gradient? -2/5 times x minus, our x1 is 3. So we have y plus 2 plus 6/5 . And then we have y, we're gonna subtract this on the other side, plus 6/5 minus 2. So that is our answer here. Y is equal to -2/5x. So 6/5 minus 2 will give you, so let's say if this is 6 minus 10, -4/5. Let's put a red box on our final answer. So guys, you see that the gradients are same because the lines are parallel to each other, but the y-intercepts are different. Let me first make sure. So 6/5 minus 2, if we take this as 2/1, so we have 6 minus 10, beautiful. I'll give you guys a few seconds to digest. Now let's look at an example where we will be given with 1 point and we will be given with a random line equation, and we will be asked to find the equation passing through that given point perpendicular to the given equation. So let me find an example. So it says line through 4, -3, perpendicular. So line through 4, -3, perpendicular to 3x minus 4y plus 5. This is what we have. Again, they have given a point on a line, and this line passing through this point is perpendicular to this line. Now, what was the relationship of the gradients? So, recall. Perpendicular lines the gradient of one line is, you guys remember this? If not, recall. And then we have let's find the, again, you know the point slope form. I'm not writing it again, right? So we know one point. Let us find the slope. So this line is perpendicular. So first, let's find the gradient of this line. So we have 3x minus 4y plus 5 is equal to 0. So we have 4y, 3x plus 5. And then we have y is equal to 3 by 4 x plus 5 by 4. I'll just leave it in this fraction form. It should be, so we have the gradient as, but the gradient of this line through for -3 will have gradient of -1 over 3 by 4, right? That's a positive 3 by 4, which will give us eventually -4 over 3. So this is our gradient for the perpendicular line passing, for the line passing through 4, -3, sorry. So let us take the, so here, so y minus -3 is equal to -4 over 3 x minus 4. So we have y plus 3 is equal to -4 over 3x, right, plus 16 over 3. So let's solve. So 16 over 3 minus 3. So this will give us, so if we need 3, it's going to be 16 minus 9 over 3. So this will be 7 by 3. Let's put a red box. This is our answer. So that is the equation of this line passing through 4 and -3, perpendicular to the line with gradient 3 by 4. Okay guys, so we're finally done with the linear functions topic, and in the next coming classes we're going to move on to absolute values, we're going to move on to transformation of functions. So stay tuned guys. Thank you so much.